but I'm just going to let it do all the calculations every time. It's a little bit inefficient, but what I'm saying here is right now, every time this code executes, it's going to do the next steps. But if you want to be super efficient, you say if dx equals 0 and dy equals 0, then return end. Do nothing, because you have no work to do.
What is now line 46? You're saying you're going one step further and being a little more verbose and saying, okay, what's its value, or what's its what's its value?
The mistake I was making earlier when I canceled that code out was I had I'll separate them out so you can see them. I had this OPR no. That would always execute to true. Yes. So I wasn't saving myself any time at all.
So it wasn't failing, it just wasn't benefiting you at all.
It wasn't doing what I wanted. It was actually costing me more than if I had left it out in the first place. Because you have to do the, it does the check every time, but it doesn't do me any good. So anyways, long story short, you can't just check for a variable and assume that if it's assigned to 0 that it's going to be considered false. You have to actually do a comparison. If it's a Boolean, you're good.
So what I see there is that if you're coming from different languages, you should probably do some very simple assumption testing to make sure that you're getting the results that you think you should be getting.
Right. And I just want to say that one thing is that Stephen pointed out correctly. And let's go ahead and do it. There's a thing called coercion. I'm sorry. First of all, I was a little quick on the response there. Yes, Charles, you're right. If you're making assumptions coming from another language, you should absolutely sit down and confirm your assumptions, because you know what they say about making assumptions. So I've been doing it now for several years, has had no negative side effects, other than maybe a little bit of wasted execution here and there. But I was completely floored when I realized that I had been making this mistake. And I didn't realize it until I was working on some client's code, and I said, wait, that's not right. And then sure enough, it wasn't right. So, but what Stephen was saying is there's a thing called coercion in Lua and other languages. And what you can do here is you can use the not operator. I believe it's an operator or statement. And that'll coerce this variable into a Boolean. It's essentially the same as doing a comparison, because a comparison also coerces the final result to be a Boolean. So, but I like the word coerce. It's a nice. I'm always coercing or co-opting or. So let's get Bob out of here, because Bob is definitely not part of our code. You're out of here, Bob.
You're fired.
Okay, so we got 5 minutes left. I'm always doing this, but we covered the really important part here, okay? Cameras. You must walk away from today's Hangout and go play with example 5, whatever I called it, camera basics or fundamentals or whatever that was called, and just understand this and then look at the camera module. But let's go back to game. So we got the reticle, very boring. It's just, we talked about it previously. Nothing has changed about our reticle. Run this code so you can see it. I didn't mess up the code. Get in the front. Here's our reticle, this little white dealy bobber, okay? That's it. It just tracks the position of the mouse, and we use it for rotating our player. So what about our player? Let's take a look at him or her. Our player is created on the next line using the maker, player maker module, and the create function, and we pass in the reticle. We pass in the reticle because the player cares about the reticle in the sense that it needs to be pointing in the direction that the reticle is at any moment time, any particular moment, so that we can fire in the right direction and walk in the right direction. Player, 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 player. So let's zoom in, go to the top, go to the top. Stop running. Player maker, just like all the others. Public module, that is a table called public, is the thing that I'm going to attach all my functionality to in return to create a basic module. This module uses a lot of other scripts. Both it uses the physics, it uses common, It uses a bunch of other makers. It uses a layer maker to get the current layers. It uses the sprite maker. Well, it doesn't really, but the green archer uses the sprite maker, so I could, in theory, take this out. This will get loaded as soon as we load the green archer maker. The green archer maker is the thing that draws our sprites. We looked at it last week. Our little dude walking around gives us all the animations. The arrow maker, we're not using it yet. I'm just going to comment that out. We'll use that next week or the week after. And then we use the Math 2D plugin that I produced and you should use instead of writing these things yourself. So it uses several modules. As we improve the player and give it the ability to fire and pick up things, it's going to start using other modules. So you should expect to see this part of the file expand over time. But for right now, all the player can do is walk in these cardinal directions: north, south, east, west, and then the 4 variants: north, northwest, southwest, northeast, southeast. So 8 directions. So those are what I call the base walking angles. Now the reason that I had to have this table just in advance of this discussion is because the animations, as you will recall from last week, use north, northeast, whatever, but I needed the angles for doing some calculations. So rather than go back and forth and write very longhand code, I just simply created a table where I could pass in, I could say something like this. Well, I could basically do this and get 0 out for my calculation. As you will often see in my code, I localize things. I like to have my functions run as fast as possible, and the way to do that is through localization, as I've mentioned before. And then, as all of the modules will be, we have a destroy function and a create. Create, as you recognize from the call previously, takes a variable called reticle. I could have called it anything, but I'm a big fan of using the same names wherever I can, so I'm calling it reticle. I can call it Bob, my favorite other variable. You'll see Bob a lot in my code. If you see Bob in my code, that means I was doing some debugging. So Bob's my go-to debugger guy. So we call destroy first. Doesn't do anything the first time around, and in fact right now it doesn't do anything because there's no cleanup. Maybe later. The player is a very complicated object. I'm sure later there will be things that we need to clean up, but right now it's fairly simple. It only walks around and tracks the position of the reticle. The very first thing we do is we, as I said, destroy. Then we ask the layer maker to give us the layers. We say, give us the layers that were created previously in game. So we get those and store them here. And then we create our player. Our player, we did this before. We call the green archer maker. We call the create function. We pass in the group we want to put it in, the position we want it at, and the scaling. So we're going to scale it at a 1. If we wanted to make it bigger, we can make this a 2. That would give us a big player. We're not going to do that. So we'll stop that. The point here is not to be distracting. So there's our create function, all in one line of code. We've created our player. However, we need to do a little more work here. And actually, I could probably move this into the player maker. I might do that. So next week, this may disappear. But for now, we need to add the body. We need to make it a dynamic body because it's going to move around. It's going to use movement. And so you've got dynamic for moving bodies, static for bodies that don't move, and kinematic for bodies that can move but do not respond to forces. Well, we want our player to respond to forces because we're going to use forces to move it. And as it is moving, it's dynamic. We make the body simply a circle. So we give it a radius of 25. And if I were to turn on the debug, I'm not running it right now, you would see a little circle. I like to use circular bodies wherever possible because they're simpler. And also, I find them to be a little more forgiving and tight-fitting, especially for players and enemies. Because oftentimes, players and enemies in games will have arbitrary shapes. And so people try their darndest to make the bounding shape match exactly the shape of their enemy or player. And then what they do is they either create a shape that's too complicated, has more than 8 vertices, or they make a mistake in the winding, which is the order the vertices go in, or some other mistake. And so it's very complicated. They go through all this work when they could have simply made a circular body, which isn't exact, but it's close enough for the situation they're in. Shooters, platformers, most of them can get by with either square bodies or circular bodies.